Hello. Hello, hello. The stream is going to start on time. And there's going to be no technical issues because I resolved them all in the last stream. It's all working right away. Not many viewers at the moment though. Hello to the allegedly one person who's watching. All right. Ooh, put that mic in a better position. Hello. How does my audio sound? Is it good? Is it loud enough? I remember this was it was a bit quiet last time, but hopefully it's all good this time. Right, so what am I doing? Ah, yes, I remember what I'm doing. So, this is still connected, isn't it? Yes. So this cube is definitely not mapped correctly because if I twist the up face in the CLI, it's actually the down face that gets twisted on the preview cube. So that's definitely not correct. So I need to fix that. How to fix this? I'm gonna undo that first. Undo the up face twist. If I twist the front face, that. Ooh, that's definitely wrong, isn't it? That is definitely wrong. Ooh, yeah, that's really wrong. Okay. So what I need to do there is well, I could just do, hang on. Yeah. Oh, that makes everything white. Oh, interesting. Okay. Everything is white there. Detecting LEDs. Currently detecting LED number 0. They're all lit. Oh, okay. There's another bug then. Why do they all go white? I guess I don't have an option for black. Ah. Okay. Okay. How do I escape the LED mapping? Stop? No. Exit? Oh, that exits the whole thing. Okay. Let's go back to solved. There we go. Okay. So that's a bug. Okay, we've got to fix that bug first. Oops. So how does that happen though? I feel like that's probably because in here there's probably a color. Yeah, so there's a color called blank, which presumably I'm not actually using. I should make that black, I think, in the thing. Where do I use these though? So at some point I turn them into numbers in here. Where does that happen? There, okay. Current colors comes from calls. Aha, right. Color num. Where's color num defined? Ah, blank does map to 0. Okay, let's map that to 6. Hi, Helios. Welcome to the stream. I've just discovered a bug that means it's impossible to map the LEDs correctly. So I'm fixing that right now. So we have number 6. So now I'm going to have to edit. Here we go, these base colors. So we need another one. Black brackets for blank cells. So this one should make it possible to do the thing. I think on the preview cube, I don't think these colors are actually used, but we'll update that mapping as well. So now, oh yeah, it's that one, isn't it? This should, okay. Right, so now, is this still connected? Maybe. So now if I do detect LEDs, no, now it's connected. Let me start again, detect LEDs. Nope. Why isn't that working? Detect LEDs. Aha, there we go. Oh no, okay. New problem. So that worked perfectly fine. Yes, single spinny square. The trouble is I now can't tell where on the cube that is to map the LED correctly. Okay, I need to add, I suppose I need to add some outlines to these things. Yeah, so that's unfortunate. Tell you what, let me put this back into the solved state so it's prettier for you all to look at. Okay, so let's make, I suppose I want to put the preview cube, instantly solved. I guess I want to put the preview cube into some kind of mode. Oh, let me get rid of that. That was probably for some note taking earlier. Which one's that? No, that's not the preview one. This is the shader for the preview cube. So I want an outline that is a color that isn't black. I suppose I could just make them, instead of going to black at the edges, I could make them go to white. Or I could just put a white outline around them. How about if, oops, uv.x is less than, let's call it b for border, or uv.x is greater than 1 minus the border, or it's probably an easier way of doing this, isn't there? y is less than the border or greater than 1 minus the border, then, oops, make the fragment color be white. Is it a vec 4 for the color? I think it is. 1.0. So if I do that, and then have a uniform float u underscore border size, then I can set this to get a border around the squares. Hopefully, that's the theory. And then I didn't need to do float b equals u border size. And then I need to add a uniform here. For border size, it's a 1f, which I might not have put in here yet. Yeah, I need to add that in. Uniform 1f. Okay. So I want to set u border size only if I'm in the mode where I'm mapping the LEDs. So I don't think this code actually knows if it's in that mode. It just gets told, put this on the screen, and it does. So I think, unfortunately, it's kind of impossible. However, we only need to do this once, so it's probably fine. Preview cube dot u, what did I call it? Border size. Dot set. Let's make it 0.1. And hopefully, no. What have I done wrong? Uniform 1f. Oh, I have imported it twice. Ah. Okay, fine. I cannot read. Actually, no, let's remove. Just to avoid unnecessary changes, let's remove the one that I added in. Yay! Wow, that's a really thick border though. Okay. Let's go for a smaller border than that. Here, let's set it to 0.02 maybe. Let's see what that looks like. There we go. Right, so now is this connected? Oh no, command connect. I'm sure there's a connect command. No, let's try twisting something. Connected, okay. Detect LEDs. When this thing says it's connected, it lies. It's not actually connected right now. Keep having to exit this. Oh, and then exit doesn't work. There's definitely some bug in this controller as well, but I'm going to ignore that for now and just restart it whenever I need to connect to it. So, detect LEDs. There we go, that's better. Thumping club music. Cool, right. We have a wireframe cube. So that is, how do I do this? Map. So the top face is 0. The subface is, I don't know, let's say that one is 0. Oh, it's going to be really hard to keep track while it's rotating. Okay, that's 0, 0. So that one, ooh. Oh, which way did that go? Did that go, I think that went down to 0, 3, didn't it? So that's 0, 3. So that must be 0, 6. That's 0, 1. 0, 4. 0, 7, I think. 0, 2, 0, 5, and 0, 8. Oh, but now I've really lost track. Which face did that go onto? Oh no. Oh no. Okay. Da, 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 da. Yeah, it does. I should stop the cube from rotating, I think. But I need to be able to rotate it so that I can see the back. And I don't want to have to add in like mouse controls to rotate it or something. I can't be asked to add in mouse controls. Okay. The other issue is, even if I get this mapping working, it's not going to work because I don't actually remap the squares at all at the moment. Like the software doesn't actually take on the new mapping. Right, exit from that. And then in here, yeah, I think I need to fix this so that it does actually accept the new mapping. I think, yeah, here we go. So there's a default LED map. When does that get read? Oh, it just sends it to the device. Ah, okay. Right. CM. So I need the test device to pass CM blah blah blah. Okay. Oh, it sends a carriage return and a line feed. I wonder why I made it do that. That's interesting. Oh well. Would it be possible to display squares going along a gradient so you're not figuring out mapping one at a time? Ooh. Yeah. It would. I wouldn't be able to do the whole thing at once though, because there's 45 squares to map. And I'm not colorblind, but 45 unique colors would be kind of tricky. I do like that idea though. The one problem with it is none of the current infrastructure in the code makes it easy to do that. So that's a shame. Yeah. Rainbow. About numbers instead of colors. Ooh. That's another really good idea. So yes, I could make this really easy to do if I put a lot of effort into it. But the fact is, I only need this to work once. And then once I know the mapping, that's fine. I could even just manually figure out the mapping. How do I want to do this? Well, I definitely need this to work. So I got, yeah. Let me make the mapping code actually work. So the cube device. Where is the cube device? Is that in this file? I think so. Test device. Yeah, here we go. So the test device So when I write to the test device, yeah, here we go, here we go. No, it's not, well, it's the test device or the idle device. They both need to do the same thing. I think I can do like that. Is that allowed? Does that work? No. I should probably fix some of these warnings. Ah, yeah, pipe. That's what I want. Put a pipe there. Ooh. Ooh, I'm actually getting helpful error messages in Vim now. Okay, I'm back to that. Cool, so that works. So, instead of just saying, yep, that's worked, we do need to actually display some useful stuff here. So, the test device and the idle device are both going to need to read the mapping data. Which means they will both need to know a mapping. And that map will want to be I suppose an array of 45 numbers. Yeah, I think so. I think that's what I want. Because when it sends the mapping info, where was it? How is the mapping done in here? That's for passing twist. No, that's for sending. Yeah, that's a different one. Is it actually in this file? Whoa! Oh yeah, okay. Yeah, I mean nothing else matters in there, so I can just do that. Oh. Variant idle. Eh? What's going on there? I don't understand that error message. That one to be like that as well. Okay. Why is that like that though? I don't understand that. Okay. The mapping, yes. So this wants to know a mapping, and it wants to be. So let me do this. You are more than welcome to lurk. Lurkers are welcome in my stream chat. Watching someone type out all the numbers from 0 to 44. What exciting content. Yeah, is that it? Does that work? That does work. Wow. It's incredibly verbose. But here we go. So this now knows its mapping. And that should fix that error, yeah. It's just to do, okay, so this test device now is missing. Sorry, clone it. Okay, that's fine. That can know the mapping. Let's twist, and then can I just do that? Does that work? What, copy? No. Gonna have to do that. Yes, that works. Okay. And then in here, if I clone this, I want to clone the mapping as well. Oh, it's so much effort adding a field to a tuple struct. Same again there. Okay. Is that all of the errors dealt with? Yes. Okay. But now I need to actually pass the mapping and update that. No, that's less important than. That's a less important task than actually making use of the mapping in the preview cube. That's more important. How am I going to do that? So currently, in that shader, where is it? Where's the shader? Here we go. So currently in the preview cube shader, it just picks. Well, no, it's not the preview cube. It's going to be, yeah, because I want this to affect the actual output as well, not just the preview cube. So in here, so this shader needs to know the mapping. Currently, it figures out. Right, yeah. So, okay, so it knows I. So I is a number that just counts up 0 to 44. So should I pass the mapping into the shader? How do I pass in the things? Okay, it's an array of 54 items because it includes the bottom face of the cube, which is not used. I just want this I here to be yeah. So whenever I look up colors, so here I want something that essentially says J equals look up I in the mapping, but I need to pass the mapping in. So I suppose the way to do it is like this. Uniform U underscore mapping 45. Yeah, that should work. And then have a uniform here called mapping. And I want to update that whenever I render this. Oops. Give me the syntax highlighting. There we go. Not the preview cube. This one. So whenever I set all these, I should also set the mapping to oh, wait, no, the test device doesn't care about the mapping. Why did I add all of that code to the test device so that it can know about the mapping? I don't actually need to do that. A mapping of 0 to 44 to 0 to 44 feels redundant. Yes, currently it does just map 1 to 1. But eventually that mapping will be something else. once we figured out what the something else is supposed to be. Yeah, where do I get the mapping from here then? Instead of writing, what was it, CM? Yeah, here we go. Okay, so that writes directly to the thing, the LED map. I'm guessing I update it at some point. Yeah, right. Okay, so at that point there, I do device.write, blah, blah, blah. So that's where the map is updated. I should keep a copy of it here. Yes, normally this layer of the software wouldn't actually care about the LED mapping. It just needs to pass it on to, yeah, to the other thing. Ah, and here it does know when we start detecting the LEDs. So I suppose I could have the borders appear and disappear during that. But anyway, that doesn't matter. Client event update LED map. This is in, yeah, this is in the main thread. So I reckon what I want to do is have a mutable mapping here. Let's call it LED map. And that is going to have to be, oops, an arc new mutex new mapping of 0 to 44. So I'm going to have to specify, no, that's fine. Okay, what was that big long list I made before? Here it is. So let's copy that one. Put that there. And let's hopefully that will allow it to infer the type, and then I won't have to figure out what the exact name of the type is. Yeah. And then we'll need to make a copy of it in here, just like I do for these, so that the Jumbotron thread can access it. So I'm going to do arc clone on LED map equals LED map, and then pass a reference to the LED map into that thread. And now I can share the LED map between the threads. So now I need to update it in here. I want to do update LED map. Okay, config.LED map equals new map. So new map must just be a string. So then I want to do LED map dot lock dot unwrap. That should get me a reference to it. So I want to do, let's call it LM. So if I do that and then do star LM, well, no, I better iterate over the, you know what, let me just print that for now, just so that I know what that looks like, because I'm pretty sure it's going to look similar to this, and that every pair of digits is a Oh, in fact, yeah, it is going to look exactly like that, isn't it? Yeah, okay. No, I don't need to do that. Because that is the same. Yeah, configuration mode, blank mapping, M. 0, 1, 2. Yeah, okay, okay. So I can just do in here, I in 0 to 40, 0 to 44. New map is just the string. So the number is going to be new map. And I want to take a slice from. Can I do that? It's a string. Is it going to let me do that? Is it efficient to do that? Maybe. Anyway, I times 2. What's the syntax? Is it dot dot? I plus 1 times 2. Like that. Yeah. And then I can do lm I equals oh, how does pass work? Oh, I'm gonna have to go and read some documentation. Rust pass int. From str. Ah, yeah, okay. No, that's the way I can do it. Okay. I can do. Is that U32? Yeah. So that should do it. And I guess we want to unwrap, but let's make it reliable. Let's do unwrap or turns the contained OK value or provided default. Yeah, that's what I want. Unwrap or let's just put 0 in there. Okay. So that now should know the right mapping. So I'll tell you what we can do actually. I would like to pass it there and do unwrap or 0 there, and if num is greater than 44, that would be a problem. Then I equals 0. Otherwise, actually set it, and that's now going to be just num. There's a better way of doing this. Okay. Whoop. What's that? Expected a reference to str, but found str. Okay. Let's do that. Yeah. So that is that. Now I need to... Oh. Use a underclad type arc. What? That's definitely not a thing. I've imported it here. Oh, maybe it doesn't know that this feature is on. That's weird. Okay. So now, where is it? The Jumbotron thread. So in here, I need actually a new argument at the end here. Oh, there's a lot of really long arguments to this function. Let's have a thing called LED map, which is an arc mutex U32 array of size 45. Okay, now we can pass the LED map into the rendering, into the shader. Here. Okay. So let's have a quick little scope for this so that we're not holding the mutex for too long. Let LED, no, call it LM equals LED map dot lock dot unwrap, and that is going to be ampersand LM. No, it should already be a reference, I think. And now is it happy with that? Yes. But the syntax highlighting has gone again. Ugh, Vim. Okay, does that work? No. What's wrong with that? Ah, yes. New map. Right, so I need to clone the thing. 1189. Here I need... Ah, yeah, I need to clone that there. And then what? Oh, found a mutex guard. Really? Line 914. LM. Oh, yeah. Okay. Shader. So I want to dereference it and then take a reference to it. Is that the fix for that? Maybe. Something needs to be mutable on line 1190. Yep, indeed it does. Aha. Ooh, mapping undeclared. Oh no, I've ruined it. The image just disappeared. Okay, mapping undeclared. Because it's called U mapping, not mapping. That's what it is. Okay. No, it's still wrong. Initializer of type uint cannot be assigned to a variable of type int. Let's make that a uint then. Yay! Okay, right. So now, detect LEDs. Okay. Let's just do the obvious mapping. I need to do it. I need to make sure it's definitely completely wrong, so that it's obvious that it's changed. So let's map. Oh no, I suppose I could map the rest to 0, 0. Well, that didn't work. Okay. Let's just see what's in LM at that point. So that looks good. Reconnect that. And detect LEDs. So what happens if I just map everything to 0, 0? And that whole thing is 0, 0. But it's still drawing the whole thing. Oh, no, I know why. I know exactly why. Oh no. Oh, that's a problem. Oh no. It's in the target folder. Here we go. Let me kill that, I think. Yeah. Okay. Oh, sorry, I'll have to suffer with nothing on the screen for a little while. I'll delete that and rerun it. There we go. Okay. So in the shader code, it's still using I instead of J in all of the places where that is used. Oh, but it calculates. But it calculates it from the X and the Y pos. Yeah. So now I have to go back from J to the X and Y values. No, is that right? No. Where does it use I? It must use I somewhere else. Yes, right. So when it's looking up the color, it uses I, but it should be using J. And there as well. That's all it needs to change. So now, we do that. Run this. Detect LEDs. Map 0 to 0. Map to 0, 0. So I map all of them to 0, 0. The whole cube should be white. So maybe I'll map them alternatively to a white one and a blue one. Then it should be obvious. Yay! Okay. Cool, I can remap the cube now. All right, it's time to actually fix the cube mapping. Okay. Detect LEDs. Currently detecting LED number 0. Oh! Oh! But it thinks that half of the LEDs are LED 0. Yeah, that's no good. That's no good. So let's fix that. So I need to, I think it's called start detect LEDs. Yeah, so in here, LED map update. So here, we need to do a similar thing to this. So when I start detecting the LEDs, just like before, make a copy of that. But this time I want to set the null mapping. So I want LMI to be I in all cases. So that, no? What have I done? Oh, expected you to find new size. Yes, of course. Fine. Just do that. That should work. Cool. Right, let's try again. Pack LEDs. 0, 0. Map requires 2 parameters. I gave it 2 parameters. What? I put a space at the end. Ah, that's a bug I need to fix. And then map to 40 as before. Do the really annoying tapping again. Okay. But now, if I rerun the detection, it should revert back to the original mapping and give me just one LED lit. Perfect. Okay. Right. So, I think maybe I need to make the border colors different on the different faces, and that will enable me to actually track the cube rotation. That's probably going to be the easiest way to do that. Then I'll know which face of the cube I'm looking at, and that should enable me to actually map out this cube and get it working properly. And then I'll be a step closer to being able to actually do some nice animations on this cube. For now, though, I am going to quickly take a break. I have a button for this. I have a button for taking a break. Here it is. I'll be back in a minute. All right, I'm back. So, what do we have? We have a cube that rotates and can be mapped. But I need to be able to distinguish between the faces in the preview cube. Oh, you know what? Before I forget, actually, I want to remove that from there, because I don't need it. And it was a mistake to try and add that in there, so let me fix that now. No more unnecessary stuff. What else? Right for cube. Yeah, I don't actually need to read the mapping data in there. Don't care about that. That's fine. When I create a thing. Oh, how did that work? Interesting that that worked at all. Or did I already remove that one? I think I did. And then here, get rid of that. Doesn't need the mapping anymore. This was all a mistake. There we go. Does that work? Yes. Okay. So border colors. Yes. Right. I want to make the borders. I want to make the border color on the preview cube. Where are the shaders? Here are the shaders. So on the preview cube, the border color here. I do have a uniform that does the colors. Yeah, u_base_cols. If I just index into that, how big is that? That's a vec3, so I want to do I want to make that into a vec4 by adding in, no, I guess I'll 1 at the end. And then I need to index this with, the current face. Yeah, there we go. And we can see green is on the blue face, so that's not right. Orange is on the green face. Blue is on the yellow face. Wait, hang on. The yellow face. No, the yellow face shouldn't be next to the white face. That's wrong. Okay, so these are not. This mapping is not actually correct. Because it includes the yellow face, which is the one that you're not supposed to be able to see, and it does not include the green face. Oh no, it does. It doesn't include the orange face. Yeah. Okay, these are not the right colors, but that's fine. The only thing that those colors are used for at the moment is this, so I can just change those colors. That is an option. I can just do that. Where is it? Here we go. That's that one. Right. Here we go. So actually I only need yellow shouldn't exist. We don't need the black one. We want to do white. White is on the top. That's fine. Red is in the right place. Blue is where green is. Oh, you know what? I need to go and find my actual Rubik's Cube so I can look at the colors on it and see where the colors are actually supposed to be. Hang on, another quick break while I go and find a real Rubik's Cube. Cube obtained. Right. Here we go. Real cube. It's not solved though. So give me a minute. But you can't even see what I'm doing, can you? Solving the cube. Just out of shot. Once again, I am a professional entertainer creating very exciting content. Watch me not solve a cube. Right, here we go. Here we go. So, okay. So I want to compare that to my rotating cube. So, it's definitely wrong. You can just look at the centers. Yeah, that's true, Maddie. But okay. So if you're comparing the webcam to what I'm looking at, that's going to be wrong because I'm looking at the opposite side of the cube to you. It's easier if it's not just the centers, but it's the whole thing. Right, so the thing that's currently green should actually be orange, which lines up. So if I swap green and orange around, and then rerun this, I think... wait, did that actually change? Yes, it did. Wow, that was fast. Okay. Yeah, so that, yep. Okay. I think the borders are now correct. Yes. Good. So this should help me. Right. Okay, so, haha. Brilliant. Ooh, it's a little bit warm in here actually. I'm gonna open the door a little bit. That didn't work. Let's try again. Detect LEDs. Haha! Right. This time it's gonna work. So that is face 0, subface 0. Yeah! That one is going to be on 0 for a while. That should be number 3. That one is 6. That one is 1. That one's 4. That one, I believe, is 7. Is that right? Should be adjacent to the red face. Yeah, that's 7. So that one is 2. That one is 5. And that one is 8. Okay. Now this one. Where is it? Where is this face? There, it's on red. So I'm going to map to it's going to be something 6. Back 0. Must be 1. 1 and then 6. Yeah, front 1. So that's 1, 6. Yeah. That's 1, 7. That's 1, 8. That's 1, 3. 1, 4. 1, 5. So this is presumably 1, 0. When we get there. Yep. 1, 1. Oops. 1, 1, 2. That is 4, 6. I think. At the bottom of the blue face. Yeah. 4, 6. That's going to be 4, 7. 4, 8. So probably 4, 3. Yep. 4, 4. 4, 5. 4, 0. 4, 1. Wait, was it 4, 1? It must be 4, 1. Yep, 4, 1, 4, 2. Okay, orange face at the bottom. So we are on the back face, which is number 3. And then it's the bottom furthest away from the white face, so it's 6. Hello, silliest Bogan. Welcome to the stream. It circled all the way around, but I was busy saying hi to the new viewer, so I missed it. It is 3. Yes, face 3, number 6. So that is correct. And then that's 7, and that's 8. Cool. I thought so. That one is adjacent to the blues. That's 3. 3, 3. That's 3, 4. That's 3, 7. Slightly glitched, but never mind. No, not 7. Ah! Did I get it wrong? I think I got it wrong. 3, 4, and then 7. I was supposed to do 5. Oh no. Oh no. Company detecting LED number 33. I think I messed up. And you know what's really silly about that? I don't have a command to step backwards in the LED detection process. Ah! This is so silly. Okay, that's fine. LED number 32 is incorrect. I can fix this manually in the config file later. So let's just carry on. Let's get all the rest of them correct. That's definitely 3, 0. That's definitely 3, 1. And that's definitely 3, 2. Okay, just one more face to do. It is the left face. So this is going to be... Where are we? We are probably right at the bottom. So it's probably going to be 6 if it's adjacent to the orange face. Yeah. So that's 6, 7, 8, 3, 4, and then presumably 1, but I'll wait for it to come around. No, 5. I'm making the same mistake as last time. 5. Yes, because I've got to do the 90-degree rotation in my head. That is number 5 because it's adjacent to the red face. And that's going to be 0, 1, and 2. But again, I will wait for it to go all the way around. Adjacent to the white face in the center. Yes, that is number 1. And finally, number 2. Ta-da! Okay. It's a little bit scrambled. Oh. It's really scrambled. What? There's too many white faces there. What are you planning to display on the cube? I'm planning to display a cube on the cube. So for context, for the new viewers who are just joining us, I Oh, I don't have the thing nearby. So you see down, where is it? I can point down there. That is a photograph of a giant Rubik's Cube that I made in 2022. Wow, 4 years ago. To take to a festival called EMF Camp, which is a wonderful, wonderful event. Highly recommend everyone goes to EMF Camp. It's very fun. It's a giant Rubik's Cube. You can play it. You can see, well, you can kind of see in the photo. There's little paddle switches. You can go click and it twists. But would I have seen that cube? I don't know. I don't know if you've seen it before. But anyway, there's only one LED per facelet on that cube. That one. I gotta look at where the camera preview is. It has some nice animations on it, but like it's very limited the kind of animations you can do when you've only got one LED per facelet. So I'm planning to replace all of those LEDs with big LED matrices. So each facelet will have a 48 by 48 LED matrix on it, which massively increases the number of LEDs and hopefully the brightness of the cube and the level of detail I can put on the animations. Because when you've got 100,000 LEDs instead of 45, you can have shaders. So that's what we're doing here. We're working on that. But I have to correctly map what I see on the screen to what's actually on the cube. And I have failed to do that. I have completely failed to do that. I think I've got the top face correct. The top face looks good. The middle slice almost looks good. We've got a straight orange. The back is supposed to be orange. It's like, how have I got the blue face so bad? I've managed to... I don't know how I've done this. I've got an edge that's a green and a blue. That should be impossible because green and blue are opposite colors on the cube. Oh, excuse me. Yes, I'm trying to map. So, oh, is my cursor visible on here? Do I get a cursor? Oh no. Oh, okay. I can't point at things with my cursor. Well, maybe I can point at things in OBS. Oh, I don't know. Anyway, okay. Imagine I'm pointing at the thing. Wait, I can do this. Over there, in that corner of the stream, where you see just above the spinning cube, that grid that's the output of the shader that ultimately is going to be displaying things on the cube, and then there'll be some software that maps each one of those squares to one LED panel. But I don't know where exactly those LED panels are on the cube. That'll just be arbitrary because when I assemble this in the field, I'm just going to plug things in randomly so that they all work, but in some kind of order. So this piece of software here is the thing that allows me to, once I've built the cube, figure out where I've put all the panels. But I need that to work so that like this is me making sure that works. It did work on the old cube. Like this is mostly the same software. But I also I want this preview to work nicely so that I can actually make some shaders and see if they work. So that's why I need it to work here. And I've just completely messed it up. I don't know how I got it so bad. Maybe I should just try again. No, what I could do. I can actually open up a text editor. Got a text editor here. And then write out the mapping commands as I do them. And then if I mess up, it'll be fine. Red and orange on the same corner. Yeah, that should be impossible. Red and orange can't be on the same corner. Where's that? Oh, is that corner that's just coming around? Yeah, yeah. See, that's impossible. I don't know what I've done. Maybe if I mean, presumably, if I twist the top face. Oh, wow, that really didn't work. Yeah. Oh. This is supposedly twisting the top face of the cube. It's like the white on the top should be staying the same. That's fine. Let me twist the right face. Okay. Wow. I just got this completely wrong, didn't I? How did I get it so badly wrong? Yeah. Yeah, it's messed up. I mean, it looks... So the top face, when I'm twisting that does actually match what's on the terminal output. So that's fine. The right face doesn't move. So I think I've accidentally mapped something from the top of the cube onto the right face. So maybe if I do, like if I twist left. Yeah, there we go. I don't know how. I don't know how I did that. I must have just fumbled the... yeah, I fumbled something. Okay. Let's go back to the solved state. Let's try running this again. But this time, I'm going to map it out in here. Okay, so that is definitely 0, 0, right? Because it's the white, orange, green corner, and it's the top face. The top face is 0, and its subface 0, because that's that corner. So map 0, 0. So that's definitely correct. I'm happy with that. So I'll put that in there. And then that is, we go down by 1, so that is 0, 3. I'm pretty confident that's correct. So I'll write that down as well. And paste it into there. And that's going to be 0, 6. Now we're back up to the top, adjacent to the orange, so that's 0, 1. 0, 5. Oh, have I messed up already? No. Oh, wait, sorry, I missed your previous message. It's going to be 0, 0, 0, 3, 0, 6, 0, 1, 0, 4. Let me check my notes. 0, 0, 0, 3, 0, 6, 0, 1. Yeah, this one's 0, 4. And that's 0, 7. I think you are correct. That's a 0, 7. Yeah. And then that last one is 0. Well, no, it's not the last one yet. I've got 3 more to do here. Chasing the blue, 0, 8. No. Ah, this is where I went wrong. That is 0, 2. 0, 2. Well, no, I didn't go wrong on the top one. I think I got the top one correct. 0, 2. That one is 0, 5. And that is, by a process of elimination, 0, 2. Right. No. Ah! 0, 8. That one is 0, 8. Yeah, that one's 0, 8. I already did 0, 2. Oh my god. Oh, it's so hard to get this right. It's fine, it's fine. I'm writing down all the commands as I do it. If I mess up, it's quick to get back to the same point this time. Don't worry. I think, oh, it's going to be the same nightmare in the field. I don't know how I did it last time with this software. My goodness. I think I will have to make this process a bit more robust. I just need an undo step, I think. Okay. Right, where are we now? So that is the first face done. Yes, so front face is 1. It's right at the bottom, so that's number 6. Yes, map 1, 6. Agreed. Paste that in. And then this one is going to be 1, 1. So what, let me get enough of these. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, I've got them all here. So, right, let me look at this again. Right, so it was 1, 6. And then, when it comes around, I think it's going to be 1, 7. Yes. 1, 7. And then presumably after that, 1, 8. Yes. So this one's not too bad because it's in the same orientation on both images. So that's number 3. So I think it's going to be 3, 4, 5 on this one. Is that right? 6, 7, 8, 3, 4, 5. Yeah. 3. That's definitely 4. That's definitely 5. And that one is 0. So it's going to be 0, 1, then 2, I think. Uh, 0. Okay, I'm now highly confident that I've got this right. Okay, right. So now we are on face 4, the right face. So make 9 of these. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, we're right at the bottom, so we're going to be on 6. Oh, is it going to be the same again? Is it going to be 6, 7, 8, 3, 4, 5, 0, 1, 2? It should be, actually. I think so. I don't know. But yes, this one is definitely 4, 6. That one is 4, 7. So yes, that adds up so far. Next one, 4, 8. Come on. Yeah, that's 4, 8. That's 4, 3. Whoops. Ah. You can't see my text editor, but it's doing silly things. No, did I do that right? I got distracted by my text editor losing focus. Yes. That's 4, 4. That is 4, 5. Yeah, okay. 4, 0. Yeah. Okay, so that is the same. Maybe I should be less cautious now that I have a way of kinda undoing. Okay, right. Great. So now we are on the back face, which is face 3. 3, 4, 5, 6, 7, 8, 9. Okay, is this also going to be 6, 7, 8, 3, 4, 5, 0, 1, 2? It is not. Yeah, that is going to be 0. Oh, this one's a real mind bender because of the way. Okay, so it's adjacent to blue and yellow, which is number 6. It is number 6. Yeah. 3, 6. So I think it's going to be the same again. I think it's going to be 6, 7, 8, 3, 4, 5. I think faces 1, 2, 3, and 4 are all going to have the same order to them because they're just the same digits rotated around. I think it's just the top and bottom that are going to be unique, and we don't have to map the bottom anyway. So Faces aren't white and yellow. Yeah, exactly. Yeah. Cool. So 6, 7, 8, 3, 4, 5, 0, 1, 2. Maybe I should just send it. Maybe I should just copy paste that whole sequence of commands in straight away. Should we do it? Should we be so bold? Ho 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 ho! Ha ha ho! Okay. Now we're on to phase 2. And let's do this again. 5, 0, 1, 2. So I'm just going to make a note there. That is the place we got up to that we were confident we got correct. 6, 7, 8, 3, 4, 5, 0, 1, 2. So let's copy and paste that in. No. It's still wrong. How? There's still something wrong. How? We've ended... So, I guess I didn't do it quite so badly wrong before. Because we've got... So the top row is all white. So that's already enough white faces. And yet there's 4 more halfway down. Yeah, it's very similar to before. I think I did make a mistake previously. But I've made fewer mistakes this time. Perhaps 0 mistakes. However, there is still a bug somewhere. Why would that be? Why would that be? So, presumably... Yep, LED map update. It updated correctly. So if I go and look at... what's it called? Test config. LED map. So there's the map. And it should look like what I've got written in my text editor. Oh, that's fun. Why is that null? Huh. Okay, that should be 48. But the default is 48, so that doesn't matter. 0, 0, 0, 3, 0, 6, 0, 1, 0, 4. That map does look to be correct, according to what I've got here. Oh! No, I know what it is. I know what the problem is. Yes. No, the all necessary colors from the bottom right. Yeah. So I know what I did wrong. I know exactly what I did wrong, and it's the index. The index of the face is actually supposed to be. It's 2 digits, and those 2 digits aren't a 2-digit number in the range 0 to 44. They are the face digit and then the subface digit, which means I need to take the first digit, multiply it by 9, and then add on the second digit. I think that's it. I think that's what I need to do. Which actually, with this layout, because it's a 5x9 grid, those mappings are well, they're not X and Y values because it's a... they kind of are, but they're kind of not. Anyway, yes, I understand now what the problem is. So I need to do the maths in... here, not there. Where is it? Here we go. So this LED map actually is wrong. Oh no, that one's right because that is the format I was expecting. Colours from the bottom right of the face going up. Going left, then up. It's a different number. Messed up for each. Yeah. Yeah, it's because I've interpreted incorrectly this thing. So this, no, not that one. That's the normal one. This one, here we go. So actually, these two numbers, I times 2. So I should get I times 2 from there. I don't need those brackets anymore. I plus 1 times 2. Wait. Okay, I've also made a mistake there. There's too many mistakes. I times 2. Oops. I times 2 plus 1, not I plus 1 times 2. That is the face num. That is the subface num. Silly code. Very silly code, yes. And then I can calculate the actual number I want from that, which is going to be fnum times 9 plus sfnum, I think. I think that's right. Let's give it a go. Did not compile. Oh no. Okay. Oh. Yeah. Right. Yeah. Wait, fname. Why did I call it fname? It should be fnum. That's one problem solved. Yes, because I can't index a string with blah 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 blah. Do not know how a bit which is not abstract works. Yeah. So I actually need to let's call it m equals new map dot as bytes. Does that actually fully convert it properly? I can't remember. And then we do that. But it's not a string anymore. It's a byte. I'm making the assumption that it is in ASCII, which is a correct assumption in this case. So I think I should just, instead of doing U32 from str, dot unwrap or blah blah blah. I just want to subtract 0, the ASCII value for 0. Which I think I can do like that. Does Rust let me do that? Yeah. As long as I put semicolons in, it should be happy. Yeah. Okay. Nope. What else have I done wrong? I'm not into. Oh, because it's a U8. Yeah. So, let me convert these both into U32. Aha. Okay. That's still mapped incorrectly. Which is weird because it should have picked up. Oh, no, okay. Other bug. We're fixing all the bugs today. The problem is, yes, this one. It should not just load the blank map. It should load the one from the file. So actually I need this code again, but less incorrectly. What do you mean, Maddie? Colors from the bottom are messed up. Oh, they're less incorrectly messed up. I think I know what you mean. Ideally the code would be correct, That is what I strive for. Anytime I write code, I strive for the code to be correct. So let's do this. Actually, yeah, where does that happen again? I want that line as well. But we're not starting with new map, we are starting with, what's it called? Config dot LED underscore map, is that right? Did I read that somewhere? Yeah, there's an example of it. Okay, that's what it's called. So we want that in here. Config.led map as bytes. Okay. Ooh. What? Where's it gone? What? Now nothing works. No. I can't even see the borders of the spinning cube. What happened there? Is it this? Yes. What? Oh, yeah, no, I know why. Because I've created a deadlock. Let's put that inside its own scope. And so that lock will be dropped. And thus it can actually start. Yes! There we go! Okay, now all of the border colors match up with the actual face colors. Isn't that novel? Cool. So now, is this actually connected? I doubt it is. Is it connected now? Right. So now, ooh. All right. Place your bets now. If I twist the up face, am I going to get the right twist on the cube? That looks good. That looks good. Do we need to check where the tiles and the faces are oriented correctly? Yes, we do. It is possible for them to be incorrectly oriented on this cube, which is a new problem. Obviously, with the original cube, oh, where's my webcam preview? I can point at it. With version 1 of the cube in the photo, obviously it's impossible for a single pixel to be incorrectly rotated. But in this one, that is technically a problem. Right now it's not, because each shader only displays a thing that has degree 4 rotational symmetry. Do I mean degree 4? I think I do. But that won't be true as soon as we start doing animations, because things will be sliding about and stuff. But yes, this works. Yeah, it's just a square. Right, let me get back to there. I'm gonna rotate the front face. So this is gonna make that blue thing be a vertical strip on the other side. Yeah. Yes! Okay. This is mapped correctly. Sneakily rotates all your pixels. I mean, if you rotate each pixel individually about the center of each pixel, that's fine by me. I don't mind. There'll be a lot of effort to do. Actually, on Cube version 1, each of the LEDs was held in with 2 screws. That's fine. 5 unrotated pixels, that's fine. Yeah, they were held in with 2 screws, so you could only rotate them 180 degrees, actually. Oh, you know what? Because they are RGB LEDs, and of course the R, the G, and the B, they're all, like, they're not all exactly in the same point, right? They're in slightly different places under the lens. They're just really close to each other. Technically, I suppose they do have a rotation because of that, which you could detect if someone had twisted it. Indeed, yeah, that's why it's so sneaky. I will never know. I will never know that you've done it. Unless I look really hard and take careful notes. Alright, let's see if we can solve this cube. Oh, it's a difficult one. It's a difficult one. Yay! Solved. Alright. If I do that... There we go. It picks a scramble. Ooh. Okay, now here's a question for the chat. Oh, you know what? I will use an engagement feature. Would you like to see? Let's solve the cube using manline interface. Yes or no? Ooh. Oh my, there we go. No, Maddie, you're not allowed to solve it for me. I have to do it. We've got 100% yes out of 2 votes. There's 5 viewers, so 2 votes is pretty much quorum, right? All right. There's only one other person occasionally chatting, so and they're not going to sway the vote. So I will end the poll there, and I will try and solve the cube. Oh my goodness. Oh, this is so... I immediately regret this. Okay, I am going to do... Because I have to type everything manually. Back face. And again. And then I'm gonna twist down face. And then right face. Oh my goodness. Should I start a timer, actually? Maybe I should start a timer for this. Should I find the 20 move solve and it takes less than 2 minutes? No. No. Oh god. This could be the rest of the stream. I'm sure I had... No, where's it gone? Oh, it's on the left edge now. Oh, what have I done? Okay. So twist down face. Yeah. Okay. So now, right, yeah. So now I'm gonna twist the front counterclockwise. Twist the top clockwise. And the front counterclockwise again. No! Ah, wait. Let me undo that movement on the top. That's correct. So I want... Oh, now I want to twist... No, I just twist... Okay, twist the right face. Okay, that's a good step. And then twist the bottom face twice. Yeah. And then twist the top face. Yeah. Yeah, you're right. Oh, yes, timer. I was going to set a timer. Hang on. Let's just make a note of when I started. It was like a couple minutes ago. So that was 14:42. I'll make a note of that. Started at 14:42. Because I don't think the number of seconds is going to be important here. I think it's going to take a while. Okay. Twist the... So, this edge... Does my cursor show up on the stream? If I hover over this window? Maybe. Yes, it does. Okay. So... millisecond precision. Nah. Yeah, so this... I want to... Right, okay, I got it. Yeah. Up face... backwards, and then right face backwards, and then up face forwards. I think that is going to put this red white edge. You know, I could be looking at the actual spinning cube instead of looking at this map. That might be easier. But yeah, that red white edge I think is going to go into place when I do that. And it did. Excellent. And then, and then is it just need to do the back face? And that should put that final white edge into place. Yes, okay, there we go. Ooh, and I've got one of the white corners in place already. I'm starting with the white face, just in case that wasn't obvious. So now I think I'm gonna do, I need to twist the whole cube. Oh, did I implement? Did I implement these twists? No, I didn't. Oh no, I can't rotate the whole cube at once. So I need to do. Which one is? No, I don't want to do the equator. I want to do the twist S. Yeah. So that twisted in that direction. Right, so maybe I want to do M. Yeah, okay. So twist M, L, R prime. This should twist the whole cube. Yeah, there we go. So now the white face is on. Hi, Daphne. So now the white face is on the front. And if I do it again, now the white face is on the bottom. Okay. That is where I would normally have the white face while I'm solving this. Daphne, welcome to the stream. We're doing a very silly thing. I've taken a break from writing code to try and solve this cube using the command line interface. So we could be here a while. EMF tickets soon. Have you not got yours yet? I managed to get mine already, but I volunteered last time, so I get the sneaky priority ticket process. I also haven't submitted the proposal to take this cube to EMF. But I don't think their call for proposals is open yet, so right, I'm talking instead of solving a cube because I'm procrastinating. So let's see. I want to put, I think I want to twist the top face. No, that wasn't quite what I wanted to do. Put that back. That was actually in a good place. So now I want to do the orange face, which is currently the one with the red center. So that's the back. So I want to rotate the back counterclockwise. Yeah, you got to be fast with the EMF tickets, unfortunately. Normally there's a bunch that go spare near the end. If you happen to know, if you're associated with any hackerspaces, sometimes they get a bunch of priority ticket codes. So it's definitely worth asking around to see if there's anyone you know who has priority tickets. Back face. Yeah, the red one. So I'm going to rotate that counterclockwise. Then I'm going to have to rotate the front. No, the top counterclockwise. And then put the back face back in. I think that's going to insert another corner for me. Yeah. Okay. Oh, I see the blue, red, white corner is already in a good place. So that's going to be back face. Then the up face. Clockwise, and then the back face counterclockwise. Yeah, there we go. Plan to be in the UK anyway. Last minute tickets. Yeah. Yes. I think normally when you buy a ticket, you can. Yeah, obviously with last minute tickets it's harder. If you get a priority code, you can buy 2 at once. So I think we did already have another corner lined up on the top. No, maybe not. No, there's only one corner left to put in. And it is the orange blue corner. So I need to twist up face counterclockwise 1 step. Yeah. Then it's going to be right, up, right inverse. And that should put that in. Okay, we have 1 face solved. Okay, so edges. Ooh, I see the blue red edge in a very good place for being inserted. So that's going to be back face clockwise. Oh my goodness. Back face clockwise. Up face. Back face counterclockwise. Up face counterclockwise. That's going to eject the thing. Yeah, then I'll need to do 1, 2, 3. There's 3 moves. One of them is going to be the back face. So that's going to be the left? No. Back. It's going to be the right. So it's going to be the right face counterclockwise, I think. Then the up face counterclockwise. Then the right face clockwise. I think. Let's send it. I think that worked. Red and green edge looks ideal. Is that the one that I just put in? No, I put the red-blue edge in. Red-green edge looks ideal. Where is that? Yes, almost. Okay, if I do 1 step counterclockwise on the top, twist E prime. I think. Where is it? I have to wait so long for it to move around. Well, the green-orange edge probably would have been a better one to do. Green. Yeah, the green-red. Okay, the green-red edge is in a good place. In fact, it's the same. Oh, no, it's not quite the same. I can't just copy-paste the thing. Right. So the green face, that's the left. So it's going to be the left one clockwise, up face clockwise, left one counterclockwise, up face counterclockwise. That's going to go... Yeah, it's going to put that there. Then I want to do the orange face, that's a front face, counterclockwise, up face, counterclockwise, front face, clockwise. That's going to put it in. No, I messed up. Oh no, I messed up. Okay, let me undo that. F prime, U, F, U, L, U prime, L prime. Is that the inverse of what I did before? Yeah, okay, so what did I get wrong? Which edge am I trying to do? I'm trying to do the green-orange edge. Oh, but it's not in the right place. because I got the yeah, I did it wrong. I did it wrong. Okay, so now that will put the right one in. No, it still won't. Hang on. Which one am I going for? Green, orange. I've decided I'm going for the green orange one. So front face clockwise, up face clockwise, front face counterclockwise, up face counterclockwise. Then the left face counterclockwise, and the top face counterclockwise, and the left face. That? Yeah, there we go. There we go. Okay. So now I think I want the red green edge to go in. Oh, let's do the blue orange edge. So let's do that. Actually, since he moves in bulk, I'm try and do full F2L. Oh my goodness, no! I veto that suggestion. I find your suggestion amusing, but I veto it. Okay, what are we doing? Blue orange edge. So that's the right face. Pre-move the entire solve. So right face clockwise, I think. Yeah. Up face counterclockwise. Right counterclockwise. Up clockwise, I think. That's gonna... Yeah, that's correct. Then... No, that's not correct. No. No, that's not correct. Ah! Which one am I doing? Green, orange? No. What color am I doing? No spoilers, I gotta figure this out. I'm doing the blue orange one. Yeah, so I need to do the orange face, which is the front. Ah, right. Front face counterclockwise. Up face counterclockwise. Front face clockwise. Up face clockwise. Yeah, so that is gonna put it there. So then I want to do right face clockwise. Up face clockwise. Right face counterclockwise. And I think I think that's gonna do it. Did that do it? Did. Yes. Okay. We've got one more edge to put in place on the second layer. I need to do top face first. And I think that lines up nicely. Does that line up nicely? Red, yeah, 'cause that's the red face coming into view. Okay, so on the green face, so it's the left, and I want it to go clockwise, and then up face clockwise, left counterclockwise, up counterclockwise, back face counterclockwise, up face counterclockwise, and then back face. Woo-hoo. My goodness. Okay. I think I want to orient this so that the blue is on the front. So that is... Does M... That... I have to do twist. Twist M. No. M, is that what I wanted to do? No, not M. E. It must be E. Yeah, of course. Equate. E for equator. And that twists with the same... Oh, that's the same as if you're looking at the bottom of the cube. Okay. So... just E, D, U prime. Should twist the whole cube. Yeah, there we go. And I wanted to put blue on the front. I think. Yeah. Okay, this is good. This is good. I could have done that. Never mind. So now it's F U R. Yeah. F front up right. There's a rotation. There is a notation that lets you rotate the entire cube. I think you sort of, if you just imagine an X, Y, and Z axis. Oops, bashing the mic. I think there is a notation where X, Y, Z, and X prime, Y prime, Z prime is rotate the whole cube in the specified axis. But I haven't implemented that in this interface, so I can't do that. Anyway, front up right, up prime right prime front prime. Is that what I want to do? Yeah, there we go. Okay, and then I'm gonna do the up face twice, and then right up. Right inverse, up, right, up to right inverse. Oh, there was an EMF ticket sale today. I didn't even know. Congrats on getting the tickets. Okay, did I get that right? I did. And then twist up face twice again, and then run that again, I think. Yeah, there we go. Oh, we're making fast progress now. Okay. Now I want to do let me twist the up face twice. And I want to do, oh my goodness. Am I allowed to Google for algorithms? I set the rules here. I'm allowed to Google for algorithms. Okay. Rubik's Cube T-Perm. Oh, good lord, not this website. I have to untick 1,000 boxes before I'm allowed to view it. This one? Come on. Yes, that one. Okay. Right up, right prime. Up prime. Right prime front. Right 2. Up prime. R prime, U prime. R, U, R prime, F prime. Is that it? R, U, R prime, U prime. Oh. Just give it the twist command. R, U, R prime, U prime. R prime, F, R2, U prime. R prime, U prime. R, U, R prime, F prime. Okay, I think that's correct. Yeah, so this particular one, like, I know, yeah, I can do it in front of the camera, I think, if I can see my camera preview. I know how to do this one with muscle memory, right? I can do that. But I can't do it any slower. So I can't slow down enough to be able to write down the thing. Because I've forgotten the sequence. Anyway, I think this should solve the corners on the top layer. Yes, well, if I do that. There we go. Okay, and then we want to do, okay, now this one I can remember. Left twice, then the down face clockwise, yeah, then the up face twice. And then, oh, no, I need to remember the, what's that move called? Oh, you know what? It doesn't matter because I can do a slight variation on it. So I've got, so that's going to put that there. Up face twice. Then normally I'd want to do that slice, but I can do that with left and right prime instead. And I don't have to get, I don't have to remember the awkward notation. Then do front twice. Then do right and left prime. And then undo the down movement and the left movement. Nice, that worked. Okay, so now if I just twist the up face twice, run the same thing again and again, and then twist the up face until it's in the right place. There we go, stop the timer. 15:06. So how long did that take me? What's that? 24 minutes. It took 24 minutes. Yeah, I'm excited for EMF as well. Well, I can't be too excited for EMF, because I got to get this cube finished first. And yet here I am procrastinating, solving the thing with the command line interface purely for content. You're all a bad influence on me. You're delaying me getting my installation built. Anyway, okay, right. That's enough of that. Ooh, look, you can see all of the cube states we went through. Oh, it wasn't even that many. Wow, did we really? No, that can't be right. Oh, no, that's just while we were... Yeah, never mind. Okay. Is it? I don't know. Yes, I had to check everything was working. Maybe you'd like to fix my Haskell typing maze for me. No, I see what you're trying to do there. You're trying to distract me. You're trying to nerd snipe me. No, I'm not having it. No, I do not need procrastination. I need the opposite of procrastination. Okay, what's the next thing we need to fix? Orientation of the faces. That's going to be an interesting one. I do need a way to set those, but that only becomes a problem once we start doing animations on them. Ooh, I can probably actually. Where are we? The opposite of procrastination. Anti-crastination. Yep, that's what I need right now. I need anti-crastination. Right, where did I set the border size? Yeah, there we go. If I set this to 0, will that look nice again? Yeah, there we go. Okay, we don't need those borders anymore. We have a correctly mapped cube. It's all good. Right. This is the fun part. This is where I get to do actual animations on the cube faces. Yes, you do. Everyone needs to bring cool things to EMF. More cool things at EMF is always a good thing. Equivalently cool as a giant Rubik's Cube. Yeah. If you can pull it off, go for it. Oh, I've just noticed that border logic is making really tiny glitches. If I set the border size negative, presumably that should fix that. Okay, not glitching anymore. Good. Okay, turning the border off means making the border negative. That's fine. Cool. Right, I think I'm going to go to the toilet. Got plenty of water. I'll be back in a little while to start making some animations work. It will take a while, by the way. It won't be impressive straight away, so, you know, don't get too excited. But I will be right back very soon. All right, I'm back. Hope you didn't miss me too much. But I hope you did miss me a little bit. Okay. I have no idea how I'm going to make these animations work. Let me explain one of the problems I'm facing. So, behold, I know how mirrors work. It's not, oh my god, the webcam does that annoying thing where it's not actually a mirror. So if I go this way, I actually go that way. Wow. In German, WB is pronounced VB. Ah. VB. Welcome back. Okay, so the problem. One of the problems. In the shader code. Wait, let me show you the shader code as well. Ah, where's that? Where is that? There it is. Here we go. This is the preview cube. No, I don't want to see the preview cube. I want to see this one, the one that actually generates the thing. Here we go. Main. Excellent German accent. Oh, thank you very much. Better than I can speak English with a German accent. I was hardly even trying. So here is the shader code. Oh, it's slightly obscured for you by the thing. Can I do that? That last bit is not too important. If I go there, well, you can almost see all of it. That if statement's not too important. Okay. You want to pretend to be a foreigner in the UK? I suppose that'd be useful sometimes. Right. So this code, it checks to see. So obviously, right, it's running a quick how shaders work for anyone who's not written shader code before. This code runs once for every pixel in the image. So essentially main is called 100,000 times approximately to make that, which way am I pointing? That image in the top right of the screen, just above the spinning cube. So each time it does it, it checks, that's what this if statement does, it checks, am I actually somewhere in the image as opposed to below it where the cube is or off to one side, whatever. And if it is, it figures out which, well, this is where it does the maths for figuring out where within a facelet it is, if indeed it is in a facelet. Then it figures out, okay, this is the bit that we just fixed. It then looks up in the mapping to figure out which square it's actually in. And then it will, so that's the bit that calculates the coordinates inside the facelet. And then this line and this line get the base colors of what was there before and what is there now. And it's just fading between them, which actually, I've just realized, we can't see it doing that because config, no, what's it called? Test config. So in here, oh no, it's not in the config file, is it? Oh, it's in, I know where it is. It's in here, in my silly little thing that makes it possible to always have the latest thing on the screen even when blah blah blah. So instead of the idle device, I will use the test device. And now, if I run the latest version of this, it should, yeah, there we go. So now it's automatically making random twists so that we can see the animation. And currently, the animation is just It just fades from what was there before to what's there now, which is obviously not what we want. Shiny. Yeah, shiny. Hang on, let me move that so I can actually see the cube again. Cool. So now what we want. Right, now I get to explain the difficult part. So suppose we're at the point in the shader where we're shading this little facelet here, this red one. As I do a twist, what I need, like obviously that's going to go from being red to being blue. But on the way, let me see if I can illustrate this a bit better by doing a twist like that. Okay, so now, okay, yeah, different approach. That red one actually is now going to become white. But as it twists, you're going to see in the same space, briefly yellow, and then blue, and then white. So I need to cycle through those two colors on my way to white. So the first thing I have to do is all of the maths to figure out what other facelets are going to pass through where this facelet appears. Which is not trivial. I'm back in procrastination mode. I want to solve this cube now. Oh no, what have I done? How do I get back? Ooh. Oh no, this should be easy to solve from here. What have I done? What am I doing? Oh, I don't know. Nope. Ah, I ruined it. Never mind. There we go. Okay. Oh, it's too hot again. How am I going to do that? How am I going to do that? All right, thank you for joining. Hope you enjoy the sun. Okay. So the shader is going to need to know what twist just happened, but also which faces intersect this one. So I think what I need, so the first thing I need is a mapping of what facelets could interact with this one that I'm currently looking at, I'm currently rendering, for each given twist. That logic is complicated. It's really complicated logic. Where do I even start with that? When it's on the same face, that's easy enough. Maybe that's where I should start. I should start with, if the face is on, if this facelet is on a face that is being twisted. Because that's the really easy case, because then I just need to know for the corners, only one intermediate color. Ooh, no, okay. Better place to start would be making, yeah. First of all, figuring out what direction each thing is actually going in. Yeah, okay. forget the intermediate colours for now. I should just handle the outgoing colour and the incoming colour, which means I need to know whether it's a center, an edge, or a corner that I'm animating. Okay, the easiest thing to animate is a center, the center of a face that's currently rotating. That's where I should start. The center of a face that is currently rotating. So within the mapping, so I kind of do want the raw mapping as well from I need a mapping that goes from I to the face number and from I to the facelet number. That's what I need. Okay, so more uniforms. Okay, oops. So I want a uniform for mapping. Let's call it uniform map face num and uniform map subface num. Is there 45 of those? Yes, there's 45 of those because I don't need to care about the bottom face. Yeah. So umap face num, umap subface num. Oops. Missed the underscore in that one. So these two. So I'm going to have to maintain this separately as well. Just to avoid computing it on every frame. Yeah, I think I should. So where I set this mapping. Yeah, here we go. So I also want to set in here map face num, map subface num. But these are going to be not that mapping. They're going to be something else. I also need to know which face is twisting and in which direction whenever there's an animation active. But I'll ignore that for now. So the face num and the subface num, I think I'm just gonna have to, you know what? Maybe it's time to get rid of that line. Just to avoid passing excessive amounts of state into into this thing. Let's create a new type called LED map with a field called raw map, and that can be the thing that calculates it's going to have to store all three mappings. Yeah, this will work. Hang on, before I do that though, before I commit to that, let's define the type and some logic for it. Yeah, it's done a similar thing with twist info. Struct for what are we going to call it? LED map. I haven't used that name somewhere else, have I? No. Okay. Let's call it index map, which is 45 U32s. Should it be U32 or should it be U size? I don't know. We'll find out. Face map. All pre-computed. Wait, no, these are commas, aren't they? And then a subface map. Okay. There's a disco ball now. I don't know what you mean. There's no balls in sight. Only cube. We have a disco cube. Okay. Index map, face map, subface map. And then let's do a little pull for the LED map. We'll give it a function called... There's a disco cube now. That's better. That's the spirit. So a function called set, and that's going to take... I suppose this should take a string, since that's the format that we get the map in. This is also going to help me duplicate the code from before that... let's see. Sandnut self. And the map is going to be a string. So that logic is going to be the same as this logic. Except that's going to be map. Convert it to bytes, do all the logic, and then self dot index map I equals that. Oops. And then we also want to set the face map for I to the face num and the subface map to the subface num. Cool, okay. How do we initialize one of these? I guess we want to do so new, get a blank one. We want that to return a self. So let's let the LED map be a new LED map where the index map is 45 zeros. Will it let me do that? A face map and a subface map. Make them all zeros, and then just do lm.set blah, and then return lm. And this is going to be, here we go, the default LED map. Cool. Does that work? Nope. What have I done wrong? Oh, yeah. Wait. No. What? What have I done wrong? Oh, that should be a capital self. Yep, fine. Oh, yeah, those arguments missing in 916 and whatnot. Fine. Yeah, that wants to be a self. So that all works fine. Yeah. Let me just not do those yet. They're not being used, so it's fine. Cool, that still works. So now I should be able to just do yeah, replace this with LED map new. And I can delete all of this. And we'll get the default map. Is that enough brackets? Yes. And then in here, instead of doing this, I can just do lm.set config.ledmap, and then all of this logic can go away. But I'll leave it there for now. And that's going to cause a problem down here where we update the LED map. Here we go. This I want to do .set new map. And then, yeah, again, let me just comment this out for now. And then in the Jumbotron thread, which is up here, we want this to use an LED map. And then instead of using LED map directly, I want to use lm.indexMap. And now I can actually set these properly. Oh, I might be able to get away with not using that. Oh, no, I should do, yeah, I just don't need the star anymore, I think. And that's going to be lm.faceMap, and that's going to be lm.subfaceMap. Cool. Right. Does that work? Probably not. No, what have I done wrong? Yes, on 1241. I don't want to pass it the actual string. I want to pass it a reference to the string. And then in there as well, 1167. Same issue. Easy to fix. And then 1231. Yes. Okay. Right. All surface is blank. Oh, no. I shouldn't be doing... Should I be doing that? I should be setting it to this. Which I think is the same thing, right? lm.set like that, and then I don't do this. Does that work? Looks good. Cool. That's working. All right. New mapping type works. So now I can remove all this code and all of this code. I can probably avoid binding this as well, because I only use it once now, so that's better. So I can just do that, and because I'm not binding it, I think I can get away with doing that, and I shouldn't deadlock. Yes, good, okay. It's still mapped correctly, right? I'm gonna wait for it to solve. Does it solve? Yes. Yes. Okay, that does appear to be mapped correctly. Good. All right. Yeah. Now what? Now I need the shader. Now I need the shader to know what twist is happening and what to do about it. Which face is being twisted and what direction it's being twisted in. So, this is where it's going to get exciting. Is it always true that, yeah, so 4 is always the center face. 0, 2, 8, and 6 are always corners. 1, 3, 5, and 7 are always edges. Yeah, okay, so I can rely on those numbers to figure out if I'm on a corner or an edge or a center. So that's fine. So the thing I want to do now is I need to add in a uniform called it's going to be of type uint. It's going to be called uTwistFace. That's going to be the last face that was twisted, and then another one for twist direction. And I think I'm going to make that a float, and that's going to be a 1 or a -1 depending on the direction. I think 1 for clockwise, -1 for counterclockwise. I think that's going to be the best way to do that. Maybe. I don't know. Let's find out. So, uTwistFace, uTwist. Oops. uTwistFace. This wants to be a uniform 1I, and uTwist, which wants to be a uniform 1F. Let's just check I've done that right. I have. Good. So, somewhere, I think this is a thing called last twist. Yeah, here we go. Right, so here's where we set the uniforms according to the twist. So we can add in here shader.uTwistFace equals lt dot hang on, what's in twist info? Twist. Ah, the twist is a twist. Right. No, not that kind of twist. Wah. Oops. Ah. Twice event twist. Oh my god, there's so many things called twist. There's a thing for triggering a sound that's called twist. There's a internal message called twist. That's the one I actually want. Cube model twist. So actually, what I want to do really is go to here, look at the cube model. This is actually documented, so I could open up the documentation as well. Twist. Okay, so it has a face and a flag that tells me if it's reverse. Okay, so yeah, so 1, -1 if reverse, else 1. And oh no, I can leave that there. Where's last twist used? Used here. Here we go. So last twist dot twist dot, is it called face? Yeah. So last twist face can be that one, And the twister is if, no, don't need brackets, twist dot inverse, reverse. So if it's reversed, it's -1. If it's forwards, it's 1. Okay. So if I'm on the twist face in the shader, so let's have, do I have, is there booleans in GLSL? I can't remember. Presumably there is a boolean type. So are we twisting this face? That is the question. And the answer to that question is, does the what's it called? UMap face num equal U twist face? So that tells me if I'm currently twisting the last face that was twisted. Let's have also some bools for is center equals UMap subface num I equals, well, that should be a double equals that one, equals 4, because the center is number 4. That's the easiest case, because that just rotates about its center, just spins about its own center. The old color and the new color are the same. So, in that case, so if this face is twisting and we're looking at a center facelet, then I want to rotate FL coord between 0 and 90 degrees. Oh yeah, because I can't do double twisters modeled as 2 separate normal twists, so that's fine. I never need to care about double twist. So it's always going to be a 90-degree rotation, never 180. Is there a... OpenGL does have 2x2 matrix type, right? Presumably mat2 is what it's called. Go and have a look at the Chronos wiki. Matrices. Yes. Mat n by m. Ooh, you can even have rectangular matrices. Wow. Okay, but I want a mat 2. So, rotation. Mat 2 rot equals. How do we do this? Well, I need an angle as well. Let's call it A. And that equals pi. Is pi a built-in constant? GLSL pi constant. No, there isn't one. Wow. Okay. Fine. do, maybe not there, I don't know. Is that a thing? That'll do. So we want to do pi is 180 degrees, so I want to do pi over 2 for 90 degrees. And I want to multiply by u and impos. And I also want to multiply by u twist so that it twists in the right direction. Okay, 2x2 rotation matrix. I can't remember what order all of the things go in, so I'm gonna Google that. It is cosine, minus sine, sine, cosine. Cosine, minus sine, sine, cosine. Of A. Okay, and then FL coord equals FL coord multiplied by our rotation matrix. That should maybe work. Let's run it and see what's broken. Twist. Oh, I have to unwrap the twist. Oh, because it might be none. Yeah, okay. Fine. Where is it? In here. Yes, this one here. Okay. So I want to do if let some twist equal lt dot twist. Then I can just remove that. That should work. Nope. What have I got wrong? Expected uniform 1i found u size. Oh, dot set, of course. Because they are uniforms. Like that. Ah, what now? Oh. Expecting a an I-32. Right, fine, okay. It's always going to fit. So let's do it as I-32. Ooh. Unexpected new identifier. Oh no. Okay. Line 17. Is there not a way to do a constant? JSL constants. Oh, do I have to specify the type, maybe? No. Oh, different error. Unexpected square bracket. 7. Ah, no. Line 37 in the shader. Which is this shader. Line 37. It's probably this one, isn't it? Have I just got the syntax wrong? Is it that? Nope. Ooh, okay. C-style initialization requires later version. Fine. So line 31. Operands of equals must have the same type. Do they not? Oh no. Okay, let me deal with that in a minute. So I can't initialize those like that. So do I have to do that? Can I do that? Does that work? Nope. Really? Do I have to do all of these individually? Maybe. I might move that into a function that does that. Anyway, for now this should work. Value of type float cannot be assigned to variable of type vec2. What? Oh, okay. 1. That's probably how to do it then. Yes. Okay, but oh, there's been a black screen for so long. Very sorry. Which one of these is it that is incorrect? Is it that one? No, that one's fine. Subface num was 4. Really? Is that the one that's wrong? Aha, right, that works. Fine, okay. So, really? New map subface num was equals 4. Subface num is a uint. What? Really? I can't compare a uint to the number 4? What? Or you? Does that work? Yes, it does. Okay. Aha. Ooh. Hey. Okay. Okay, it's rotating about the wrong center, and it's always rotating the top face. Interesting. Interesting. Well, okay, so I need to do some, I need to translate over by half, and then back again. So yeah, I'm definitely going to move this now to a function. That returns a match 2. I will call it rotate. It will take a float called A. So now, hopefully I can do rot equals rotate A. And this should, oh, no. Ah, got to return rot. Okay. And this should, yeah, just completely fail. Fine. So we need to translate it by, minus a half. Spooky, yes, very spooky center tile. I'm rotating about the top left corner, but I should be rotating about the center. That's the problem. So I don't believe that GLSL doesn't have a way of specifying a literal matrix. Must be a way to do it, right? Oh, is there a function called map2 that will just do it for me? Yes, there is. Ah, right. That's what I'm missing. Right. So I can do this. Turn these all back into commas. Here we go. And this should be the same kind of spooky broken. Nope. Oh, it's different kind of broken. Syntax error. Unexpected bracket. Oh, is it not like trailing commas? Grr. Okay. Still broken. Which is good, because it's broken in the way I was expecting. So we got the rotation there. So let's also have a matrix called translate. It takes an X and a Y. Actually, that can just be one line, no assignments. This is going to be the same. It's going to be a matrix. Oh, this one. Yeah. I should make these all mat3, shouldn't I? Because then I can actually do proper transformations with them. So it's going to be 0.0. That's going to be 0.0. And that's going to be 0.0, 0.0, 1.0. I think that's right. Yeah. And this is going to be a mat3. Oh, but now I won't be able to translate that thing unless I extend it, which is fine. Just need to do that. Make this a vec3. Add a 0 on the end. And swizzle it. Back to that. Anyway, this is going to be 1, 0, X 0 1 Y 0 0 1. Okay, so here's the magical fix. I want to translate by 0.5 0.5 after rotating, translating by minus a half, and I think that puts the rotation center in the right place. No. Nope. What have I done wrong? What if I just always translate by a half? Is it actually in pixel space rather than unit space? Maybe. This is weird. This is really weird. Is it in pixel space? Do I need to make that 12? Well, that should be minus 12, I suppose. No, not 12. 24. 24 is half 48. No. That seems to be... Also, there's still definitely a problem with the... it's always picking the same face to twist. Why is it always picking the same face? It is correctly picking a center face. Am I not setting U twist face correctly? Show me that. Okay. Yeah, now I need to. So that is working. But it's not showing me the right face. It's not twisting the right face every time. Huh. Whoops. Okay. I don't know why this is happening. Well, anyway, let's get the center of rotation fixed first. FL chord. Oh, I see. No, I don't want FL chord to change. Where do I sample? No, I don't. Oh no, it is It is the FL chord. Pixel pulse.x minus that, and then divide by the face of the pixels. So yeah, so it should be in the range 0 to 1. What if I was to just translate an X by A? Let me just make sure this translation works correctly. No, that doesn't translate at all. Have I messed up the translation matrix? Multiply by 1 and add X. Right? That's correct, isn't it? Oh, no, I know what I've done wrong. Yeah. I know exactly what I've done wrong. That number is supposed to be 1, not 0. Ah! Okay. Now it's going to do funky things. No, it's not. What? Why? Oops. Oh, wait, that's still 0. That's going to be 1. Ooh. No. Okay. It's rotating about a different center? Oh, I translated in the wrong direction. Is it that order that I wanted? Yes! Ah! Okay. The center tile has animation. Yay! But only on one face. For some reason, always on the top face. I don't understand why it's always on the top face. That's very strange. That is really strange, that one. So, I need to debug that. So I would like to know twist.face. I'm going to do that just in case. Twisty twist. 1, 6, 8, 6, 2, 7, 3. Wait a minute. 0, 2, 3, 7. 7? 7? There's only 6 faces on the cube. How am I getting 7? What? Let's kill that one. How am I getting 7? Maybe this doesn't work how I thought it does. Oh, right. Yeah, fine. These are fake faces. Yeah. So the center slices. I need to. Oh no, but that's fine. No, that should still work because then the test should just fail for those numbers. Yeah, so I can only assume that the mapping, the face mapping, is incorrect. So what must be wrong is yeah, in here, face map. Let's see what's in there. Dot face map. 0, 1, 2, 3, 0, 1, 2, 4, 3, 2. That looks fine. And then I index into that with some number. Oops. Map face num. New map face num I. I must be always getting 0 from it though. That's weird. That's really weird. If anyone has any idea what might be going on here, please let me know. I want the spoilers now. This face. So I'm always checking, is this face, according to the map of the face nums, equal to the currently twisted face? I'm guessing that must always be 0. So if I put a 0 in there, this would be a good way to test it. If I do that, now all of them should twist all the time. Oh. Oh. Okay. Fine. 0U. I know what's going on. It's only rotating the top center. Hope this helps. Yeah. Thanks, Maddie. That really clears it up. So, it's only if that equals 0. But that, okay. Even if that's always, okay. Let's say true. It is always this face. All of the faces should look the same now. All of the centers should twist at once. Yeah, there we go. Okay. Which is still wrong, of course. But that means that this is doing something. So U underscore twist underscore face. Is that not being set? No, it is being set. And it's being set correct. I think. Oh, does this not have the right value at the right time, maybe? But I'm only setting it if it does have the right value. So it must have the right value at some point. Now you see, this is one of the really awkward things to debug. Because inside this shader code, I can't just do like printf some number. Even if I could, finding the right pixel to run it on is tricky. Like, oh, I'm going to run this code 100,000 times. Which one do you want me to printf for? All of them? I know what I can do. I can do so U twist face, which I'm pretty sure that is I'm gonna pick the base color temporarily from U underscore map underscore face num for I. Just to see what that looks like. It's gonna look wrong. Ooh. Okay. I don't understand. It's this. We're twisting this face if the face num for face I, which is the one that we're doing, is you twist face. What? Why isn't that true? Why is that not true at the right time? Why is that only ever true? Why is it always true on face 0? It's like u twist face has the wrong value. I'm setting u twist face. Uniform 1i. From 1i. Oh, what if I make this a uniform 1 ui? Then I'm gonna get a type error from Rust. Yeah, okay. But that's fine, because I was already converting it unnecessarily, so I'll just not do that. Oh, right, no, I can't find it. Uniform 1 UI. Add that in there. Uniform 1 UI. I should maybe just import all of the uniform types at once. Now I still got a type error. U32. Wait. You can convert. Oh yeah, it's a U size. I need it to be a U32. Okay. Fine. Let's make that a U32. It should just work. Okay, is this gonna work? Oh, yes! Hey! But those faces are not the right faces. Right? I don't know. I'm going to slow down the test device. Instead of every half a second, let's take 3 seconds to do the next one, and then when we're doing the twist, we can make it take a whole second. I think it's currently 300 milliseconds. Yeah, so let's make that 1,000. Okay, this should move slower, and now we should actually be able to see which face is turning. If one of these faces turns. Ooh, that might have been correct. Counting on one of the faces near the front turning. Come on. I need this to randomly line up correctly. Come on. Nope. Aha! Yes. Okay, now that did work. But it went the wrong way. Why aren't you turning them manually? That is a very good question. So, that's a very good question. I will explain why. So, yeah. What I could do is set this to idle device, run that, and then connect the CLI controller, and then, okay, so let's say I want to twist the top face. It just jumps, because unfortunately, all that does is it says, go to this state. It doesn't tell it to do the twist and then ask it what state are you now in, which is probably a bit of a flaw, really, because whenever you use that command, this thing assumes that it knows the exact state of the cube correctly. And it was deliberate at the time because it's, okay, if you connect this and you type solved to go into the solved state, you want that to be the correct state of the cube. And it would fetch the state of the cube from the thing. I think it does. It still does this. If I do that and then I exit and then I connect and I do show. Oh no, it doesn't. Oh, okay. That's a problem. I do have the anim option, but I don't think that sends. Yeah, that just plays the animation in the terminal. It doesn't actually request that the cube does it. Yeah, it was meant to be a way to minimize the possibility of the state getting out of sync. But yeah, now it's causing me a problem. What I could do. Oh, here's a fun idea for a thing I could do. I have all of the electronics for the cube, and I could just plug in the part that does reading the switches. I could just plug it into my desktop PC because it's just a USB device. I could do that and then just have a thing on my desk where I go click, and then that would let me do a twist. That could be fun. I could also create a fake device that allows me to do the twists. So similar to how the option that I use here is called idle device. And I've got the one that does the random twists and it's called test device. I could have another one called, well, I suppose the test device could implement some way of doing it. Yeah, it could, couldn't it? But alas, I have not implemented that. Also, a thing that I noticed is it goes the wrong way currently, the rotation. So I think in the shader, when I do the rotation, I want to multiply by minus twist direction. I think this is going to be correct. Yeah! Alright. Cool. So, faces, the center of each face does the right thing when rotated. There's definitely, like, you would normally be able to see these four subfaces slightly protruding into that face. So it's currently just black in those spaces. I should be able to fix that. But that's the part that requires knowing where all of the other faces are relative to this one. I think the next easiest one to do Well, I suppose all of the other faces are the next easiest ones to do. The edges and the corners. So if it's an edge, I need the rotation center. Yeah, the rotation center is just going to be different. Let's give that a go. Oh, but I need to render 2 versions of it. So I need... Yeah, I need to render it twice. I need to render each one of those twice. Once for the color that's leaving, and once for the color that's entering. Which I'm kind of already doing, but I'm just fading between them at the moment. So, you know, I render this one here and this one here, and I just mix the colors. But what I should actually do in this case is... yeah, okay. So that's the normal rendering. Looks like that. That's the thing that adds in the previous color. So I suppose I want to suddenly jump to having the new color in the other place. Rotate the previous color out, rotate the new one in. There's a lot of maths involved here, and it's kind of the boring bit. So I'm tempted to go and solve all of the rest of these problems off stream. And then on the next stream, hopefully, I can do all of the pretty bits. So it's not just a solid color on every face. It'll be something actually pretty to look at with fun, I don't know, wavy particle effects or whatever. But this seems like a good place to stop. I've got the cube all mapped correctly. I've got the centers of the faces being twisted animating mostly correctly. Yeah, we fixed a few bugs. I think I'm going to stop the stream there for today. I have been streaming for 3.5 hours now. I need to go and eat some food, so I'm going to go and do that. So thank you everyone who joined. Yes, cube mapped pog. Indeed. Yeah, thank you everyone for joining. I hope you have a lovely rest of your day. And yeah, I'm gonna go get some food because I'm really hungry. Bye bye.